Let's discuss about fluids. In this video, we will discuss fluid mechanics and its application. First, pressure and depth in a static fluid. Second, Pascal's principle. Third, Archimedes' principle. Fourth, continuity equation. Last, Bernoulli's equation. Let's talk pressure and depth in a static fluid. Pressure is defined as force per unit area, and more convenient to use pressure rather than force to describe the influences upon fluid behavior. To compute for pressure, divide the force over the area. And the SI unit for pressure is Newton per meter squared or Pascal. Let's talk about Pascal's principle. It states that a pressure change occurring anywhere in a confined incompressible fluid is transmitted throughout the fluid such that the same change occurs everywhere. It shows in the equation that pressure exerted in the input is also the same to the pressure applied in the output, thus force over the area of input is equal to force over the area of output, or simply F2 over A2 equals F1 over A1. Let's now discuss about Archimedes' principle. It states that any body completely or partially submerged in a fluid at rest is acted upon by an upward, or buoyant force. The magnitude is equal to the weight of the fluid displaced by the body. The formula now is buoyant force is equal to density of the water times volume of the displaced fluid times acceleration due to gravity, or 9.8 meter per second squared. Let's compare our first three lessons with these following examples. Suppose the pressure acting on the back of a swimmer's hand is 1.2 times 10 to the 5th Pascal, and the surface area of the back of the hand is 8.4 times 10 to -3. Determine the magnitude of the force that acts on it. Using our formula for pressure, force over area. Force can be calculated by multiplying given pressure to the area. Substituting the values. The force now is equal to 1.0 times 10 to 3rd newtons. Second, in a hydraulic system, a piston has a cross-sectional area of 20 cm squared pushes on an incompressible liquid with a force of 30 newtons. The other end of the hydraulic pipe connects to the second piston with a cross-sectional surface area of 100 cm squared. Calculate the force on the second piston. Using our formula for pressure. Force over area. Force can be calculated by multiplying given pressure to the area. Substituting the values. The force now is equal to 150 newtons. A ball has a mass of 2 kilograms having diameter of 50 centimeters falls in the swimming pool. Calculate its buoyant force and volume of water displaced. Calculate first the volume of the sphere 4/3 pi r cube. 4/3 pi times 0.025 cube is equal to 0.0208 meter cube. Then using formula for density mass over volume. Volume of sphere was used, so 2 kilograms divided by 0.0208 meter cube equals 96 kilogram. Now calculate the volume of the displaced fluid. By deriving the buoyant force equation. Volume is equal to force over density times g. So 19.6 divided by 96 times 9.8 is equal to 0.0208 meter cube. We are now done by fluid statics. Fluids that are stationary, and these are Pascal's principle and Archimedes' principle. Let's now proceed to fluids in motion. We now continue to continuity equation. It says that the volume of fluid moving through the pipe at any point can be quantified in terms of the volume flow rate, and is equal to the area of the pipe at that point multiplied by the velocity of the fluid, and it be constant throughout the pipe. The formula now is area 1 times volume 1 is equal to area 2 times volume 2. Are you already enjoying the lesson? Click the link in the description below as we continue discovering fluids in motion. Thanks.
Created using Powtoon.